Hello, good morning, good afternoon, good evening, wherever you might be. A big welcome to all of you. My name is Laura, and I'm delighted that you are joining us for today's ESPC community webinar. Today, I am joined by Benny, who will talk to you guys about using Lakehouse data at scale with Power BI featuring direct lake mode. We love hearing what you guys have to say, so remember to join in on the conversation about today's webinar and more on X. Our handle is at ESPC_community, and our hashtag is hashtag ESPC24. Tweet us, at us, and tell us what you learned. Don't forget to check out our Learning Hub, which is updated daily with the latest blogs, ebooks, and how-to videos. You can access and view the Learning Hub by visiting our website, sharepointeurope.com. Here. Continue to keep up and stay ahead by joining us for our next webinar, which is a hot seat webinar. Got your burning questions about Microsoft Fabric? Then this is your golden opportunity to get your questions answered. Join us for a 30-minute live web. Whether you're a beginner or looking to level up, get the art with John White, MVP, answers you need to kickstart your journey. This webinar is the third webinar of Microsoft Fabric Week today at CET. For more information on this webinar, please check out sharepointeurope.com/Microsoft Fabric Week. The moment we've all been waiting for is finally here. You can now view the European Power Platform Conference 2024 programme. Get ready for an immersive experience, hot topics and trends, world-class speakers, interactive panels, engaging tutorials, networking extravaganza, and much more. View the fantastic lineup of tutorials, sessions, and networking by visiting sharepointeurope.com/conference schedule 2024 EPPC, and you can find the link there at the bottom of the screen. Here at ESPC, we want to spread. That is why we are offering you this limited one-time offer, a deal we know you'll fall in love with. Why not infuse a little love into your workday by securing 30% off your ESPC 24 ticket? 2024 is the year to rekindle the flames of your Microsoft 365 passions and inspirations. Discover innovative solutions and time-saving techniques, meet with peers to share and receive ideas, hear the latest news from Microsoft Corporate, and insight from our knowledgeable speakers. And again, you can visit sharepointeurope.com/pricing to snatch up this offer while it's still available. So after the webinar, we will have a questions and answers session. Type any questions you might have into the questions window. Questions will be selected and answered at the end of the presentation. This webinar, as always, will be recorded and added to the Resource Centre, where you will be notified by email when it is available. And now I'm going to pass you over to today's webinar presenter, Benny. Hello, Benny, and thanks for joining us.
Thank you so much. Now, if all is well, I should be sharing my screen. There we go. Now, are we good to kick off?
Yep, all good.
All right, good. Thank you so much. Then let's get started. So, good morning, everyone. I am very happy to present to you a little bit about the new and shiny tool that we have within Fabric, within Power BI essentially, which is called the Direct Lake Mode. So myself, my name is Benny de Jager, and I'll take you on a whirlwind tour of what it is exactly in the next 45 minutes or so. So myself, my name is Benny de Jager. As I said, I'm based in Belgium. Coincidentally, today I'm actually working at the office in Brussels. Typically I just work from home or from a customer office, but today I'm here in Brussels, so I get to watch the airplanes take off, which is always a lovely source of entertainment for me. I work in a team that's called the Fabric CAT, the Customer Advisory Team. Long story short, we're part of the product group, and we're there to help customers. Either that is with we engage with them directly to unblock their problems, to do some debugging, to do some troubleshooting with them, But mostly it is we get feedback. We listen to their problems and we try to listen to the right signals of those problems and get those feedback signals to the PMs so that we can help them influence the roadmap and try to prioritize features that would make our customers even more happy. So on a daily basis, I do a lot with Fabric, a lot with Power BI, but I'm also involved in a local user group here in Belgium called Data Minds. Essentially, we do free evening sessions, we do webinars, we do conference, etc. So all designed to get people together to share their passion for data. If you want to reach out to me afterwards, the easiest thing to do is probably just to find me on any of the social channels. The finding me is pretty simple. I use the same handle everywhere. So if you know how to spell my name correctly, you'll probably be able to find me in any of those channels. I will say that if you're reaching out to me over on LinkedIn, I am not known to respond within a day on LinkedIn. Be patient with me. And well, I'm not a big fan of pie charts, but luckily for you, that is not the scope of the discussion today. The session that I'm doing for you today is diving into direct lake mode. How do we work with Lakehouse data at scale? But to be able to go there, I need to introduce to you a little bit about what Fabric is and what OneLake is, because OneLake is the basis for everything we're doing with direct lake mode. Now, this direct lake mode, that's for me the hidden gem. Well, not essentially the hidden gem. It's the crown jewel of what we released within Fabric, because it has the potential to solve some real challenges that we saw before in Power BI. But mostly, I'm a practical person. I just like to take things for a spin, do some demos to try to get you to understand what are some of the core concepts of what you need to understand for direct lake mode. But if we look at Fabric, it's the third session on Fabric already this week. So if you followed along with any of the previous webinars, I'm hoping this is not going to be a new slide for you. It means that back in May 23rd, 2023, we announced something called Fabric at Build, where Satya, our CEO, said it's the biggest release, it's the biggest announcements of a data product since SQL Server, which is kind of a big deal. But in a nutshell, it means that we've taken a lot of the good things from Power BI, the tenant-wide approach, the software as a service approach, and we've taken it and we've expanded that to some of the data products that we had available before. Now, in essence, that means that today we've brought a whole different set of workloads, a whole different set of experiences, and we've brought them onto a single platform. That single platform is managed centrally. It uses one source of compute, etc. But for me, the really cool part is that they all share a single basis, a single platform for the actual data, which is called OneLake. And that OneLake part allows us to do something with Power BI that we have not been able to do before. So that for me is the big difference where we're coming from these days. Because that OneLake part allows us to do something which is called one copy. And the one copy part means that whichever one of these engines you're using, whether it be Power BI with a data set, whether it be Data Factory with a pipeline, or whether it be a data warehouse, well, we all work together on that same version of the data. So we don't need to duplicate data around, which is a really cool thing. But I always forget I have animations on the slide, which is, yeah, I think I'd be used to it by now. But they all share the same form of serverless compute, and they all share the same platform for OneLake, the same platform for data to store it. Now, under the covers, we do some technical magic, but for you, if you open up your portal, if you open up the actual Fabric portal itself, it will present to you itself as a logical version, as a logical virtual Delta Lake. Now, the Delta part, that is the big thing, because the Delta part allows us to do some pretty cool magic. But if we look at what we had with Power BI before we announced Fabric, well, we had two main modes of we call them storage modes, but two main modes to work with your data. The first one is, well, you had direct query mode. Direct query mode is great because it allows you to connect to a data source and to get the data as it sits within that data source. So it does allow you to do something that's called near real time. As soon as the data is landed in that data source, it will reflect the same way within Power BI, which is good. The reality is that it is not easy to get it to perform well. It's not that easy to get it to perform well. So it is a bit slower. It gives you slower response times, but it does give you the latest results. Essentially, what it means is when you have a report, you fire off some queries, and you directly go back to the database under the underlying database, whether it's SQL, whether it's Oracle, whether it's Teradata, Databricks, Snowflake, any of the above. Good, but some caveats need to be kept in mind. The alternative, and what we see for 95% of the use cases, is import mode, which is great because you take a copy of the data, you mission match it together, and you load it into memory, which is good because memory is the fastest thing out there to read data and to present that data back into your reports. The downside is, well, you have to do a very expensive refresh operation. It takes a while to refresh that data and to get it ready to be presented in import mode. So most of the use cases, 95% of the use cases run in import mode, but well, the refresh part, we saw some issues there with some people. And then especially as we saw the industry standardizing on something called Delta, we did not have a good answer to that. So that is where that new form of direct lake mode came to fruition. That means that with direct lake mode, we're taking a bit of the combination of those two. It means that instead of doing that whole expensive refresh operation to load data into memory or import mode, well, we're now doing something different under the covers. We're going to load only the data we need, only the data we actually need on the fly, so on a demand basis. When the data is queried, then we'll look if we need the data, yes or no, and add more data if we actually need it. So yes, that's no refresh added to it. And it does mean that as soon as we have that data in memory, well, it does give us that same level of performance that we had with import mode. So it really has the potential to unlock some new use cases, especially when you're already standardizing on a Delta lake. But why are we making such a big fuss? Why are we making such a big deal about Delta? Well, Delta, if you're not familiar with it, which is perfectly fine, is, let's call it a framework. It is essentially a framework for how to work with data stored in a data lake. It is a way of how that file is written on disk, and it is the metadata that they keep around it. That's essentially Delta. The good thing is, well, Delta is an open standard. It means that it is open source. And yes, that is Microsoft actually working on an open source format that is shared with other vendors too. That's how serious we are about this. We believe that Delta really has the power to be a very strong competitor for the next 10 or even more years. And that open standard can be contributed to by anyone. That's a very good thing. But it is mostly column oriented. So mostly when you look at how data was stored or how data is stored within flat files or in databases, well, we work on a row basis. Now, under the covers, Power BI does a very similar thing, or has been doing that very similar thing for a long time, where we store data based on a column format and we index and we encode it that way. So it allows for very good compression and it allows for excellent encoding, which means is we make the data very small so we can read that data at the way that we need it very fast as well. So making it as small as we possibly can to improve the response times when we're querying it. And well, it is slowly but steadily becoming the industry standard, which is a very good thing because that means that more companies, not just Microsoft or Databricks, they're adopting Delta as a valid standard for storing data in a lake. And well, it is also well suited for something that's called pruning, meaning only select the things that you actually need instead of the whole file. And it thrives on bulk operations, on big reads and big reads, big updates, etc. Now, if we look at that, let's take a sample file. We look at a file here that's just a basic table with some fruit sorts in there, a quantity and a custom name. Now, the column format is excellent for reading, select some quantity and group that by. Those are the types of operations that it thrives on. It's really good for that. It's not so good for something that's called point lookups, for individual updates or individual inserts or individual deletes on that file or on that table. It's not so great for that. It will do it, it will just be a bit slower. So the purpose there is mostly for read in the analytics departments, read in the analytics use cases. But if we look at how the thing actually works, and I'm keeping it simple here. We don't need to dive into the specifics way too much here. It means that we do something that's called dictionary encoding. So if we have a value that is apples, oranges, and pears, well, we create an integer value next to it, basically. We make a dictionary so that it points to, well, if we have that value, that's the actual value we're pointing to. Right now, that means that for the product size we have here, we need about 30 characters and 30 bytes to store that data. But if we imply that dictionary encoding, well, we can already reduce that size because we need less space to actually store that. The dictionary that we're building on the side also takes some size, but we're still reducing on the actual data that we're storing here. But we're also doing something cooler, which is called bit packing. And bit packing means that, well, for those values, we actually only need we need less bits to be able to store the same values. So that means we're even getting that value, the storage size, down even more, which is a very cool thing. But if you look at it even more, we also do something that's called RLE, run length encoding, where instead of repeating the values, well, we just say that value will now be repeated for X amount of times. So reducing the number of times that something needs to be written in that file. So a lot of things to be explained here, but that's the basis of what the Parquet file does and what Delta does for us. So these things allow us to really make the size of a file smaller and allow us to read the data faster afterwards. That's essentially the thing. Now, specifically into Fabric, we've introduced something, or we have something that's called V ordering. Now, there is another standard out there, which is called Z ordering. I'm not going to go too deep into that one, but be aware that it's out there too. But V ordering means, well, we apply a proprietary algorithm. So it's an algorithm that is just for Microsoft. So only our engines, only our software products can write this at the moment. But it means that we do a write time optimization to those files. When the files are being written to disk, we apply an optimization. Basically, you need to understand it's a certain way of how we sort the data, how we distribute the data across the row groups, how we do the encoding, and how we do compressing and shuffling. That's essentially what you need to understand. We do some proprietary magic to make it work best with our engines. Now, it still applies to the open standard. So it doesn't break the way that you can work with those files with other tools outside of the Microsoft ecosystem. It doesn't break that. It adheres to the open standard, which is a good thing. The right part, that is something that we can only do today. And well, because it complies to the open standard, you still have those operations within the Delta Lake that you can still execute on those files, but that's a good thing. But if we look at it in a practical example, is okay, we've got some tests internally where we have a database which is 880 gigabytes in size. 880 gigabytes on CSV files, in flat files. If we make a Parquet file out of that, or if we make Parquet files out of that, well, we're already going down to 268 gigabytes, which is a big, big reduction already. But then if we apply V ordering, if we rewrite those files using that V ordering, we're going down to 84 gigabytes. So if you look at the difference between these two, well, that's a reduction of 3.2. That basically means we have to read a lot less to be able to get the data we actually need. So it means it's probably going to be faster operation. Now, I've got a demo case because I don't have that database available to me for actual demos, and I do prefer showing you something. Now, I've got some files, roughly about 32 gigabytes. It is data coming from the New York City bikes, which essentially means it's the transactions for the city bikes. Someone picks up a bike, they drive around, and they put it somewhere else. Now, the data size you see here, that's just the flat files persisted on disk, nothing too fancy. Now, it is a clean star schema, and I need to update that slide, 190 million records in there. So 190 million records. So big data, no. Small data, no, but representative enough to show you what I actually mean. But what I've done is I've used the pipeline to load that data into my OneLake. Nothing too fancy, nothing too special here, no special wizardry whatsoever. And on disk, that translates to a Delta file, to a Parquet file of roughly 5.5 gigabytes. So that same data just written in a different way onto my OneLake environment. But what is that direct lake mode? That is where we're actually getting into the meaty part of it. Now, when I said initially that with import mode, we do that expensive refresh operation and we put everything into memory. Well, direct lake mode starts off with not a single piece of data loaded into memory. So nothing is loaded into memory. It only is going to do something called transcoding when queries are actually started. And the transcoding part means, well, essentially we write the data into a certain way into one lake, and then we need to pick up that data, reshape it a bit to be able to work with the Power BI engine, and that's that transcoding operation. We change the way it's encoded essentially. Now, it only picks up the data that it actually needs. So that means that a single table within your data model, it can have a mix of transcoded, it can have a mix of the resident and the non-resident columns, which means not every column has to be loaded into memory. With import mode, that is the other way around. With import mode, it is the entire table has to go into memory or not. So that's where the big differences start to appear. Now, we do something called evictions. And evictions means that, well, whenever something is loaded into memory, well, we have to check if there's still room for that in memory, because we don't allow people to use infinite amounts of memory. So over time, we need to make some room. We need to clean things up. And that can be for different reasons. It can be that the data has not been used in a certain period of time, or you're trying to fit too much into memory, so we need to make some room. So that data can get dropped from memory, which means that when it's queried again, it has to be placed back into memory. But we also have something that's called direct lake fallback, which is very important and something you really need to understand. Because direct lake mode, as I said, well, it's going to go directly into the lake and it's going to only load the columns you need into memory. The fallback mechanism does something called the fallback to data query. For whatever reason, it cannot respond with direct lake mode. It's going to fall back to plan B to data query as an alternative, which means it'll be slower, but you do get your response. I've had some lively discussions with people on whether that should be the behavior or not, but that is the behavior that is there today by default. You can change it if you want to, but that's the behavior by default. Now, there is also a concept called framing, and both fallback and framing we'll get to afterwards, that basically says, well, what data are we looking at? So those are two important concepts that I want you to stop, that I want you to put in the back of your brain. Now, well, okay, let's jump into a demo. Let's jump into what I actually have. So what I have for you is, okay, and I need to cheat a bit so I don't have to wait for that session to load, is I have a workspace. And that workspace is a workspace located on premium capacity. I've got a few things in there, a few semantic models, some data flows, some pipelines, notebooks, etc. But the meat of what I'm looking at is a lakehouse. And that means that in that lakehouse, I have my data that's stored in there. So I have some data in there, which means that I have my trips table, and that is essentially the fact table with those 190 million records that I have. So essentially nothing too fancy. If I look at the semantic model that I have, the actual Power BI data set that I have, well, that is a clean star schema. It means that I've got a fact table, and in that fact table, I've got a bunch of relationships to my dimensions. And those are the ones that I'll be using in the reports that I'll show you. So nothing too fancy, nothing too complex, but it does allow me to give you actually the context of what we need to understand there. Now, this is the model that I'll be working with. If I jump into a tool called DAX Studio, DAX Studio is an open source developer tool essentially. Well, what I can do is I can query some of the details of the internal DMVs. DMVs are data management views, and they hold metadata about the actual model. So one of the things on the metadata that I want to look at is, well, I want to look at how is the data stored essentially. That's what I want to look at. So what this gives me is, well, I have the tables that I have in my model, I have the columns, some of the data type information, etc. But what I'm mostly interested in is this, and this. This is what interests me today. The dictionary size, well, it gives me some indication of how much data is actually used to store the dictionary that I mentioned before. The pageable part is, well, can I load that data into memory? am I able to load that data into memory? The is resident part, and I was a bit too ambitious with my arrows here, the in is resident part is it loaded into memory? Is it already active? Is it already cached? Is it already good to go? Now, the two other ones, the temperature and the lost access, well, what you need to understand there is lost access means, well, when did you last fire off a query that had that data in it in some form, shape, or way? Whereas the temperature part, that's where it can get fuzzy for some people. It's a magical value, basically, that we calculate, and the higher, the better, essentially. The higher, the better. The higher means the more frequently it's being used inside of queries and calculations, and the less likely it is to be evicted. Now, that's the short version there. Now, if I go ahead and I start executing some things on my model, I want to run a basic query called evaluate total trips. What that does is it's going to do a count rows measure of my table. It's just going to get how many rows do I have in my table. So the roughly 190 million that I mentioned before, that is loaded into memory. Now, count rows is a DAX measure, but the cool thing is, well, it doesn't have any data loaded into memory because it can just use the statistics that it has available to answer that question. Now, if I run another query, and this query is basically, it's a measure that executes a sum over a column, well, now I'm going to get a value here. But if I look at my DMV again, what's happening now? So for my trips table, the entire fact table, I have plenty of fields in there. Well, none of them are actually in there, except the only fields that I actually used in my query. So only that field, the column that I used to make my calculation in the measure, that is now the only thing that's persisted. Well, that's not persisted, that's cached in memory. So everything else is still out of there. Now, let me execute a slightly more complex call. I only said slightly, a slightly more complex statement. What I'll do is I'll run a column that gives me the values of the bikes that were used and the regions that were used in combination with those two measures that I used before. Now, currently I have one column that's available in memory. So now if I look at my results, still trying to execute, if I look at my results, All right, if I try to, yeah. So now if I look at my results, I'm going to look back at what is actually available in there. So this is where I've had some people be confused before, because essentially, well, we already established that total trips didn't require a field to be in memory. The total duration did require a field to be in memory. I did ask only two other fields. So why do I have 7 fields loaded into memory? Well, those 4 other fields with a low temperature that you see here, they are essentially the keys on both ends of the relationship. It needs that to be available too, to be able to materialize the relationship essentially. So we do also need those to be loaded into memory too. So for that query, I need a total of 7 fields, basically, which is something important to understand. But the good thing is, well, that's the only data that's now loaded into my memory. But okay, well, enough with the executing queries inside of DAX Studio. What does it actually look like when I'm executing a report, when I'm looking at a report? So what I've done is I've built a report on that. Thing, on the semantic model for my Direct Lake data set, essentially. Now, what I can do, what I will do, is I will open something that's called the Performance Analyzer. Performance Analyzer, if you're not aware, if you're not familiar, it is an excellent tool to help you troubleshoot performance that you might have with any of the reports you do. So what I'll do now is I'm going to look at my report. Now, that report is what I'm executing here, and that's what I'm doing. So I've opened my report. This is now Direct Lake mode in action. This is now trying to render for me a report, which means that, okay, my report is done and roughly put the slowest query executed around 12, well, around 13 seconds, let's say, 13 seconds. Now, 13 seconds for 39 million records. Now, is this that super fast direct lake mode that everyone's been talking about? Well, this is that behavior that we were talking about just before. This means that the data now had to be fetched from one lake and had to be transcoded to be made available in that Power BI dataset in direct lake mode. So we had to do some work to make it available elsewhere. Now, if I go ahead and I execute this thing again, it means that, okay, well, now I have a lot more columns sitting inside my memory. There's a lot more columns that are in there. The columns that I either put on a visual, the ones that are included in a measure, or the ones that I needed for, well, my relationships to be able to be transversed. Now, the thing is, I have this report and I have 40 million records. Why is that? Well, I have applied a filter here on my years. So I said, only give me the last 3 years for subscribers who are riding on a classic bike. Now, what's going to happen if I do the clear all slicers button here? That means that instead of the 40 million records, it needs to go look at the 190 million records that we have available. Now let's do that. There we go. So, well, this is a whole other level of experience that we have, because essentially now, well, the data had already been not persisted. I really need to say it's not persisted. The data had already been cached in memory and is ready to go. So now the slowest query meant that I'm looking at 2.6 time, where I'm losing mostly a second waiting for other visuals to be done. So there is some things that can be improved in my report design. I know it's just purely for the demo part that I have this year. So that data was loaded into memory. It meant that when I reduced or when I removed my slicers, well, it's already that import mode performance that we're aware of. So if I now start interacting with the report, well, this is more the import mode performance we're used to. This is me clicking around on a visual on a Power BI report over 190 million records, reading directly from that data that came from the lake, but reading directly from the persistent memory, the cached data into memory. Now, that is the good thing about it. So this roughly means that I hope you understand now what direct lake mode is, but now let's go look at the things that I feel that you need to be aware of. Well, we do have something that's called fallback to direct query and framing. Now, the fallback mechanism, that's the important one that I need to talk about. Well, if for whatever reason we cannot execute that query for using direct lake mode, we've made the decision by default to give you a plan B, to give you actually the results that are there. Now, those results will be slower, but I, for one, am part of the audience that feels it's better to have slower results than no results. So for whatever reason, it cannot use direct lake mode, well, it's going to check that. Can I use fallback? Yes. Okay. Oops. There we go. Let's try to read that data from what I have available in my cached memory copy. If I cannot do that, well, let's just use the SQL endpoint on my Lakehouse to try and read that data from there. That the data both comes from the same Delta Lake, from the same one lake environment, where either it goes through the SQL endpoint and reads it directly, or, well, if it's not available, if it's not resident in my memory, it's going to do that transcoding operation, read the data on the fly into the memory where it actually needs it. Now, this is a big impressive slide. Essentially, there are a few limits you need to be aware of. Depending on the SKU that you have, the capacity size that you have, there are some limits that you need to be aware of. The number of files, the number of rows you have in a table, and, well, the memory that you're using. So you don't need to memorize this. You don't need to memorize this at all. It's essentially a table that I've copied over from a documentation page that explains this fairly well. But there are some size-related limits that you need to be aware of for direct lake mode. Now, we do have some other reasons why we could fall back to direct query. Now, one of the actual limitations we have today is, well, you cannot create relationships on a date time column. A column that has the data type of date time cannot be used to create a relationship. Now you can do that with the column that is set into date. That works. That's not an issue. It's when the date time data type is actually used. Now, for most people that I've spoken to, most people that have done some business modeling themselves, this comes in as a shocker. So we don't support calculated columns or complex calculated tables. That means that for a lot of people, calculated columns were essentially a way of, well, the data I need is, or it's not in the right form, persisted into my data warehouse or my view or my source system. Let me just do that inside of my DAX to get the data that I actually need. Well, with direct lake mode, that is not an option. The data can only be read as it is persisted in those files. So that means that whatever process you're using to load the data needs to have that data in the right form or shape. Now, will we ever do it? Probably, never say never, but it's not something that we can easily do, basically. Now, there are some limitations on certain column types available with Delta, for instance, binary and GUIDs, etc., which do prove to be an issue for, well, direct lake mode right now. But one of the main reasons why I've seen fallback mode start is when you're using views, essentially. When you write a SQL-based view over on the Lakehouse or on the warehouse, well, that's going to always fall back to direct query mode. Because you're creating a construct over those files, and the data is potentially transformed from what is persisted in the file. So today, we only read the data as is, as it physically sits within those files. Now, we also don't have composite models. Composite models where you have a data set, you have a semantic model, and you add some tables attached to that. You add you have an Excel file with a budget, for instance. That is something we don't support yet today. Now, I want to look at that framing part because that's an important concept, which means that by default, you don't have to worry about any of this because we've set up default values for you that you don't have to worry about this. But I want to show you actually what I mean with that. Now, for context, what I'll do is I will go into the actual data set that I have, which is called the framing data set. Now, what I've done is I've made some changes to the default configuration. By default, there is a setting in the refresh pane here that says keep your direct lake data up to date. It's switched to on by default, which means that, well, okay, effectively, whenever new data is landed into the lake or whenever something changes, it's going to try to do a refresh operation, mostly with the data. It's going to detect those changes. Now, the big gotcha is whenever you do such a framing operation, well, you flush the cache. That data is effectively dropped from memory, and the first person that comes in, well, they have to sit through those 11 seconds of trying to get the data loaded into the memory again. So I've disabled this here because it allows me to show you what I mean, basically. Now, I have another report, which is a fairly simple report. It is essentially a direct lake data set again, over on that same Lakehouse, which has a list of my favorite YouTube channels, basically. Now, it's trying to read that data, and it is a lot slower than I'm used to. All right, so I've got 5 channels loaded in there. I've got 5 records. So that's good. Now, let me go into, I really hope my session is still active. Yes. So when I'm querying on my Lakehouse, that is the 5 values that I have. So this is going to be executed. This will be executed. There we go. So these 5 records, the ones that I inserted here above, they're going to be displayed here. Now, all right, what I'm going to do is I'm going to delete those values. I've changed my mind. I'm going to delete the values. Now they are deleted, and I'm going to insert 3 new values. I've got 3 new I've got 3 new YouTube channels that I'm more interested in. I've changed my appetite, basically. What I'm doing now is also, by the way, an anti-pattern for Delta, where I'm doing small trickle inserts, because under the covers, I'll get to that later, for every record that I'm inserting, it's creating a new file. It will lead to something that's called the small files problem, but for demo purposes, this is as quick and dirty as I need. Okay, so good. If I go ahead and if I query my Lakehouse, I will see, I'm hoping to see, go. There we go. I'm seeing my 3 new sessions that I prefer more, or my 3 new YouTube channels. Now, I'm going to refresh my Power BI report. So what's happening here? I've refreshed and it still is only showing me those 5 channels. Well, it's waiting for me to actually perform that framing operation. And framing is a fancy word for a refresh operation, but it's waiting for me. Now, if I go ahead and if I look at this model that I had here, I can do the same thing here. Well, if I do this, or I will be able to do this, is if I execute it, I've got 3 columns loaded into memory, which is good. Now, what I'll do is I will refresh that data set, that semantic model. It's a framing operation, essentially. It only takes a few seconds because it's basically moving the pointer to where the data needs to look at. Okay, so if I go back, if I do that, well, everything is dropped from memory. So the first person to execute that query, which is going to be me again, will have to sit through, well, the weight of getting that data loaded into memory. But luckily, there's also some caching happening on the Lakehouse, so I can benefit from that. But now I actually have that data back and ready available inside of my model, and it is warmed up in the cache. So the good thing is, well, by default, you don't have to worry about it. The bad thing is because, well, basically, when you have, for instance, data coming in every 10 or 15 minutes, well, every 10 or 15 minutes, you're going to flush the cache, which might not be the behavior that you actually want to do. Well, how do you cope with that? How do you actually work with that? That means that, okay, well, if you want to make it a bit more operationalized, if you want to go for a bit more of a, pro ETL version, well, there are options. It means that, well, typically you can look at ingesting your data through whatever you want to do. If you want to use notebooks, data flows, if you want to use pipelines, go ahead. Whatever you want to use, you ingest that data into that Delta Lake. When that is done, you can do something that's called the framing operation. Essentially, you call for a refresh on that data set. Then the framing operation is going to be done, and you have control over when it happens. That's the good thing there. Now, what you can also do is, if you know which queries are going to be used, if you know which queries are going to be most popular in the data set, well, you can also just execute a query yourself to warm up the cache, to get that data loaded into memory and to make that available for you. You can really do that if you want to. Essentially, it's just a post-processing step in the ETL process. Now, as I wrap up, what are some of the things you can do to work with Delta in direct lake mode? The V ordering I refer to, well, it makes a big difference. It's designed to work best with our engines. So that's the good thing. If you have all the engines within the same team, well, you can talk about what actually makes it work better. Now, is that V ordering, is that a hard requirement? No. You also have the options to run regular Parquet files. You also have the option to use files coming in from Databricks without V ordering, but with Z ordering, etc. So there are options to include those. Reality is, well, it will probably have a small impact on performance. How big? I cannot tell you, but it's because it's based on your file, your data, your scenario. Now, it will also work on something that's called a shortcut. I didn't cover this, but I'm hoping someone did in the session before, where the data doesn't have to physically sit within the lake environment that I pointed to, but it can sit somewhere else. For instance, on the other side of the world, if I want to. But if that is the case, well, it will have a performance impact as well. If data has to travel all the way from Singapore to what I'm doing here in the West Europe region, well, it has to travel across half the world. It's going to have an impact, but it is possible, which is a good thing. Now, essentially, Direct Lake thrives on fewer but larger Parquet files. So cleaning up those files is something that will always be crucial. So what I did there, and I actually forgot to show you why it's an anti-pattern, well, is if I go ahead and if I look into my files, well, I have so many different small files in there, all the ones that I created with just the with just the inserts that I've done today for a single record. It's a single transaction, so therefore it was a single record. So the bulk operations, they're important. If you're using pipelines, if you're using pipelines, etc., that's all managed for you. But with notebooks, you have to keep this in mind. Now, luckily, there is something you can do. You can click on the maintenance tab and then say, run me an optimize command. Run me an optimize command, or even run me a vacuum command. Optimize means that it's going to try to merge together some of the files to reduce the smaller files that you have and apply V ordering in there if you need. You can also say do something that's called a vacuum, which is clean up the days that are, clean up the files that are too old, essentially. I don't need them anymore, just remove them. So with notebooks, you also have the option to do this. We will also have options that it's done for you by default, but today it probably is something that you have to keep in mind every so often to actually execute this. Now, the reality is that personally, I'm not convinced today that for streaming or small batch, very frequent batch, small batches architectures, direct lake mode is going to be the solution for you. Because of the fact that the framing operation drops everything from memory, well, it does come as a big gotcha to what's there. So if you're looking at streaming or if you're looking at small batches, you probably have other options within Fabric to make that happen. Direct lake mode is not the silver bullet solution for that. Now, I still feel that the principle of lean models very much applies. Lean models means, well, if you're not planning on using it, why would you put it inside your model? Now, let's pick on SAP again. If you're coming from the SAP world, maybe you have tables that have 550 columns in there. Well, if you're only using 32 of those 550 columns, why the heck are you putting the 528 columns that you're not using into your model? It's only going to cause overhead. It's only going to add complexity. And well, if you have a zealous user that does a select star or an evaluate table query on that table, well, it's going to try to load everything into memory, which could potentially be a very costly operation. So I'm still the person that says, well, only put in the model what you actually need or plan to be using in the near future. Now, I've been working with direct lake mode for quite a while already, and I've been answering some of the greatest hits, the frequently asked questions, the gotchas, essentially, to be aware of. Delta, the framework of Delta, is not a fan of spaces and object names. Power BI modelers are a very big fan of spaces and object names. So the two of them have to come together somewhere. Now, we're doing work on that. We're trying to make it so that you can actually use those spaces and object names, but we're not there yet. So today, you do have to be aware of that. Now, the delta tables, the actual create a delta table in OneLake, is a hard requirement. Direct lake mode will not work without that delta table assigned. Now, it is not difficult to create them. If you use Dataflows Gen 2 or pipelines or notebooks, they pretty much automatically create them for you. Even if you just say, I want to upload a file, you still have the option to say, the file I just uploaded, create that into a delta table. So no code required for you to manage it. It does that for you. Today, web modeling is the recommended way to create those semantic models. It means that, well, we have the web modeling experience in the browser, and that's the best way for you to use it. You cannot create direct lake semantic models in Power BI Desktop. It's not an option today. Will it be in the future? Yes, but it is still still a bit away. You can work with XML and with external tools such as Tabular Editor, but again, I need to update the slide. As of last week, you also have the option to re-enable web modeling. So you do now have the option to mix external tools like Tabular Editor and web modeling together in the same experience. If you're a person that's used to that for some of the more developer experience modeling, then that's an option you have today. But web modeling basically is the best way to get started for you. And how do you get started with the web modeling? Well, if you're in a Lakehouse, you click new semantic model, and then when you click the new semantic model, I'm just going to go here because I'll forget to do the afterwork afterwards, is you arrive in this experience. Essentially, this is Power BI environment that you've known and used to before. You can create your measures, you can create relationships, you can change some of the data types, some of the names. So you can really do that all here. The thing is, well, it's web modeling and it autosaves. It autosaves, so every change you do will probably be saved. Keep that in mind. Now, you can use external tools by connecting to the XML endpoint, but for most of the common use cases, you can actually get a long way with just the web modeling experience. Now, Direct Lake itself doesn't have any unique limitations on DAX. Data does. So if you do that fallback to data, well, then you probably have to take into account that those DAX limitations still exist. And right now, we don't have any plans to support other file formats like Apache, Iceberg, and Hudi, but well, never say never. But what does it mean for my modeling standards? How do I need to design my semantic models? I can be very, very simple on this. Star schemas are still the preferred way of creating your Power BI semantic models with Direct Lake mode. It simply works best for the engine we have underlying, and you'll get the best results, you'll get the best compression, you'll get the best performance, you get the most cost optimized way of working if you use star schemas. That does not change. Let me be very clear on that one. So essentially, it means that, well, with that Direct Lake mode, it means that we need to follow Roche's maxim. And Roche's maxim means, well, I have a colleague on the CAT team, and he says that data should be transformed as far upstream as possible and as far downstream as necessary. For Direct Lake mode, it means data needs to be persisted in the way that you're going to use it in the actual files. So no more workarounds using Power Query or using DAX. It needs to be persisted in the actual file, which is a really, really crucial takeaway. So I've got some resources, mostly links to docs, mostly linked to blogs. And then if you're interested in the slides, I didn't discuss this with Laura and Ellen, if they will share the slides afterwards. If you want to get the slides, they're over on my GitHub. That said, I do feel that we've got time for questions now.
Brilliant. Thanks a million, Benny, for a great presentation and a great demo. So we'll just get stuck into the questions now. So again, should you wish to ask a question, please feel free to type it into the questions window or into the chat. So the first question I have here is, someone wants to know, can you confirm that one needs Fabric like F42 capacity to use OneLake with Direct Lake mode, i.e. a capacity on premium P1 does not make this available?
All right, so Direct Lake mode works with, I'll jump back to the slides, works with any F or P capacity that you have. Really should have just skipped back in the actual slide. Works with any F capacity. So F2, you can start. It works with anything going from F2 up to F2048. The P1s, the premium capacities, that also works with Direct Lake mode, because essentially the demos that you've just seen, that runs on a premium capacity, on a P1 capacity. So Direct Lake mode works with whatever capacity that you have, even the trial ones. Now the confusion may be there that for something else called Copilot, there is a limitation on the SKUs you have to use. For Copilot, we say it has to be F64 P1 or above. But for Direct Lake mode, no, it works on any of the SKUs with F or P.
Brilliant. Thanks a million, Benny, for answering that question. So I don't see any more questions coming in there. So we might just wrap up the Q&A session. So that is it for today's webinar. Thanks again, Benny, to yourself for taking the time to carry out this webinar today. We really do appreciate it.
Yeah. So yeah, will you be sending out slides to registered attendees?
Yes.
Yeah. All right, yeah. Good. I'll send those over as we wrap up, and then you can send those out. Okay.
Brilliant. Thanks again, Benny. And again, the webinar recording will be sent out to all the registrants as well via email when it's available. So that is it for today, folks. Thanks again to everyone for joining us, and I hope that you'll join us again soon.
All right. Thanks, everyone. Bye.
Bye, guys.